Dear students, welcome to the course on Statistical Methods for Psychological Research Part 2. In this lesson, we are going to learn properties of sampling distribution of the difference between two samples means. What are you going to learn in this lesson? Let us look at the learning objectives. The first learning objectives is to become familiar with the concept of the probability distribution of the sample mean. The second one is to understand the properties of the sampling distribution of the difference between two sample means. Let us start. We begin with the first part of the lesson, in which you will learn the assumptions and properties of the sample distribution. Sampling distribution. The sampling distribution helps us estimate the parameters of the population and make suitable statistical inferences. It provides insight into the potential range and distribution of values that the sample statistics can take. This image shows data distribution becomes sampling distribution through central limit theorem. When n tends to infinity, that is, sample size is very large, then any data distribution becomes sampling distribution. The sampling distribution refers to the distribution of a particular statistic, such as the mean, the proportion calculated from multiple samples drawn from the same population. It provides information about the behavior and variability of the statistic when different samples are taken from the population. Central limit theorem. The central limit theorem is a fundamental concept related to the sampling distribution. It states that for a large enough sample size, the sampling distribution of the sample mean approaches a normal distribution regardless of the shape of the population distribution. Central limit theorem. From this figure, we have different types of sampling distributions. When the sample size increases, that is tends to infinity, then all the sampling distribution becomes normal distribution. Sample statistics. The sampling distribution can be constructed for various sample statistics, such as the sample mean, sample proportion, sample standard deviation, etc. Each statistic has its own sampling distribution. Suppose we have a population. From that population we have several samples, so we can find the sample statistics for each and every samples. Variability. The sampling distribution shows the variability of the sample statistic. It provides information about the spread of the values and the likelihood of the obtaining different values of the statistic from different samples. So, from this figure there is a population, and also we can have several samples. So, we know the sample statistics and population parameters. Relationship between sample and population. The sampling distribution is connected to the population distribution through the laws of probability. By analyzing the sampling distribution, we can make inferences about the population parameters or test of hypothesis. So, the same population we consider, and we have several samples, and also we can find population parameters, sample statistics, and finally we can have sampling distributions. Types of distributions. Sampling distribution of mean, sampling distribution of the proportion, and last one t distribution. So, these are the types of sampling distributions we can see in the picture. Assumptions. Random sampling. The samples are assumed to be selected randomly from the population of interest. This means that each individual or element in the population has an equal chance of being included in the sample. This is called random sampling. Another assumption is independency. The observations within the sample are assumed to be independent of each other. In other words, we can say the value of one observation does not affect or influence the value of the another observations. Sample size. The sample size is assumed to be sufficiently very large. According to the central limit theorem, as the sample size increases, the sampling distribution of the sample mean approaches a normal distribution regardless of the shape of the population distribution. From this figure, we know that population, sample and sampling distribution of the sample mean. For the population, we have a population size capital N and population mean capital mu, population variance sigma square. Also, we are having formula for finding the mu and sigma square for the population. As far as sample is concerned, sample of population, we have a sample size n, sample mean x bar, sample variance s square, and also we are having formula for finding the sample mean and sample variance is also given. Then sampling distribution of the sample mean, we are having sampling distribution size, sampling distributions mean and sampling distribution standard deviation also. So, for that we are having formula mu x bar equal to mu population mean, the standard error it is nothing but SE is equal to sigma by root n. Population distribution, the safe and the characteristics of the population distribution may impact the sampling distribution. In some cases, assumptions about the population distribution such as normality may be required for certain statistical tests or procedures. Central tendency, the sampling distribution tends to have a central value that represents the expected value or average of the statistic. For example, the sampling distribution of the sample mean tends to have a central value equal to the population mean. The spread and variability, the sampling distribution has a certain amount of variability or spread. This variability is often measured by the standard deviation or variance of the sampling distribution. Larger sample size tends to result in smaller variability. Shape, the shape of the sampling distribution is influenced by various factors, including the shape of the population distribution and the sample size. Under certain conditions such as a sufficiently large sample size or the application of the central limit theorem, the sampling distribution tends to approximate a normal distribution. Next, the sampling distribution and population parameter. The sampling distribution provides information about the sampling variability of a statistic and can be used to make inferences about the corresponding population parameter. For example, the sampling distribution of the sample mean can be used to estimate the population mean. Efficiency and bias. In some cases, certain sampling distributions may exhibit desirable properties like efficiency and lack of bias. Efficiency refers to the ability of a statistic to provide a precise estimate of the population parameter, while bias refers to the systematic deviation of the statistic from the true population parameter. Developing a sampling distribution, assume that there is a population where the population size is a 4 random variable capital X is considered as a age of individuals. Values of X are 18, 20, 22 and 24. We can find mu, it is equal to summation xi by n, it is equal to 18 plus 20 plus 22 plus 24 divided by 4, it is equal to 21. And also we can find the population variance sigma is equal to square root of summation xi minus mu whole square divided by capital N, it is nothing but 2.236. From this image we can see the age of 4 individuals, A for 18 years, B for 20 years, C for 22 years and D for 24 years. Now, we want to consider all possible samples of size n equal to 2. How many outcomes of size 2 are there if we are sampling with replacement? There are 8 outcomes, there are 12 outcomes, there are 16 outcomes. Which one is correct? Then k power n is equal to 4 square, it is equal to 16 outcome is the correct with simple random sampling with replacement. Now, consider all the possible samples of size n equal to 2. Counting rule 1, k power n equal to 4 square, it is equal to 16 outcomes. So, from this image we are having 16 possibilities. The first observation, second observation, then we have a 18, 18 and 18, 20, 18, 22, 18, 24, and the second row represents 20, 80, 20, 20, 20, 22 and so on. We are having 16 possible samples, and also we can find 16 samples mean from that. 18 plus 18, it is equal to 18, then 18 comma 20, it is equal to 19, and so on. We can find all the 16 sample means from these 16 possibilities. In this image, we can find 16 samples mean. From this table, 18 plus 18 divided by 2 equal to 18, 18 plus 20 divided by 2 equal to 19. Then similarly, we can find all the 16 samples mean. Then from this sample means, we can draw sample means distributions like this. Developing a sampling distribution. Summary measures of the sampling distribution: mu x bar is equal to 21 and sigma x bar is equal to 1.58. Then here we divide by 16 because there are 16 different samples with the sample size n equal to 2, population n equal to 4, mu x bar is equal to 21 and sigma x bar is equal to 1.58. Sample means distribution n is equal to 2. Then this diagram shows that this is the age of individuals for the 4 people, and also we can draw a diagram with the sample means. Dear students, I hope you understood all the concepts, especially the properties of sampling distributions. We will continue in the next video. Thank you.